Okay, lesson 26, literal equations. We will learn how to rearrange a literal equation. So first, that means we're going to have to describe what a literal equation is. And after we've explained what a literal equation is, we're going to have to show how to deal with those, how to rearrange them. Now, to arrange something is to set something up in an order. So when we set something up in an order, we're talking about, A, B, C, D. When you want to rearrange something is when you start to change the order of something. Shush. So whatever the new order is, that's what we're talking about when we talk about rearranging. We're going to be doing the same thing with our formula, but we're going to do them on literal equations. Now, today's fact for lesson 26, the English alphabet has 26 characters. There used to be only 25 until I think it's the letter J. One more letter was added in the 14th century. Danish have 29 letters and Russians have 33 letters in their alphabet. Arabic have 28 letters. So it's actually, pretty small amount of letters compared to other English language, other European languages. So I think it's the letter J, but don't quote me on that. It could be like the letter Z or something like that. Let's go have a look at the first slide. Literal equations. A literal equation is an equation whose solution will be expressed in terms of another variable rather than a number. Okay, so rather than saying, oh, the answer to this is 14, you would say the answer to this is 3x plus 4 or something. So let me show you the two differences. Here, let's solve this. Two x plus 3 equals 7. I'm going to minus 3 from both sides. In chat, can someone tell me why I minus 3 rather than divide by 2 first? Or you can say out loud, either or. I want to know, why do I minus 3 first rather than divide by 2? It's a common mistake that a lot of students make.
It's easier.
It's easier? Is there another reason?
It's the last thing that happens to the variable.
Yeah. So the last thing that happens to the variable. X gets multiplied by 2, and then we have 3 added to it. I will say, if someone said it's easier, you can just divide everything by 2. You can do that. But that means you also need to divide the 3 by 2. And most students forget that part. And they go, oh, they still get the answer wrong. That means we're going to have 2x equals 4, which means our last step is going to be divide by 2, which cancels out that, which gives us x equals 2. Done. Easy. X is a number, it equals 2. Now this guy is a little bit different. 2x plus y equals 7. Now let's see if we can solve this to x. Let's find a solution for x. Well, we're going to do the same thing. The last thing that happens to x is it has y added to it. So I'm going to subtract y from both sides. And if I subtract y from both sides, it's going to cancel out that y, which is fine. We're going to have 2x equals, now 7 take away y. We can do 7 take away 3, that's easy, it's 4. That's a number. 7 take away y, we can't do really, because it's a random, we don't know what y is. So instead of doing it, we write down 7 minus y. And then the last step, is to divide by 2. So when we divide by 2, that cancels out that multiply by 2. X equals 7 minus y divided by 2. Now I can't divide 2 into 7 minus y because I don't know what 7 minus y is. So I just write it down. Think about literal equations, and a lot of students disagree with me, but I actually think they're easier than non-literal equations. Because ultimately, I don't have to do any maths. I don't have to do 7 take away y. I don't have to do any arithmetic, I should say. I don't have to do 7 take away y. I just have to write down 7 take away y. I don't have to do 7 take away y divided by 2. I just have to write down 7 take away y divided by 2. Whereas over here on the left, I have to do all this extra little arithmetic stuff here, you know? And, you know, it's just a little difference. So this is a literal equation. Oops, my internet's going bad, so just bear with it. This is a literal equation because you're not saying x in terms of a number. It's x in terms of y. So what is x? If you knew what y was, could you work out what x is? And that's what this does. And that takes this equation here into something like this. All right, I'm going to jump ahead to the next slide. Does that make sense to everyone? Can I get someone to let me know whether they're confused or not before I move on? Otherwise, I can re-explain this, but do you guys get this? Okay, thanks, Bowden. Just eating a piece of toast here, people. Don't mind me. Good. Two more examples. Let's work these ones out. Again, they're pretty simple, but not necessarily simple. Again, if you struggle with this stuff, that's fine. We're going to find expressions for S. Now, this is sort of how you would describe this. We're making expressions, or we're making some ways that you can add and subtract to get to S. And it's expression of X because we're trying to find out, well, we want to make, essentially how I prefer to say is make S the subject. Both of those are the same thing, but essentially we're trying to make S the important part of the equation. In this case, we've got 12 equals 2w plus 5s. So the first thing we notice is on this side of the equation, we've got an S, we've got a w. We don't want that w there. We're going to try and get rid of that first. We're going to minus 2w. That's going to give me 12 minus 2w equals 5s. And can someone tell me what's the last step? What do I do now? Whoop. Either out loud or in chat. Doesn't matter.
Divide by 5.
Beautiful. Thank you very much. Divide by 5. Divide by 5 because that'll get rid of this. That's going to give us, again, I can't divide 5 into 12 take away 2w because I don't know what 12 take away 2w is. There could be 10. It could be 5. It could be negative 10. So we'll just write 12 take away 2w, 2w divided by 5 equals S. And we're done. Over here, we've got 8t minus 3s plus 17u equals 0. Now, grab a look at this guy. We've got 3 separate variables. We've got a t, we've got an s, we've got a u. That's fine. We just treat it just like how we did the other ones. Now, which one am I going to get rid of first? I'm going to get rid of the easiest one first. I'm going to get rid of the 17u. To get rid of 17u, I'm just going to minus 17u from both sides. I minus 17u because initially I added 17u. So I need to undo it by doing the opposite to it, which is going to give me 0 take away 17u is going to give me 8t minus 3s equals negative 17u. Now this next bit sometimes gets people a little bit confused, but actually I usually find students get this okay, but still. The next part is to get rid of this 8t. Now there's no sign in front of this 8t, so can someone tell me, what is this, a positive 8t or a negative 8t? Maybe I should start picking up individuals. Maybe Richard, you're here. Can you tell me? Oh, someone already said. Logan already said. Thanks, Logan, for saving the day. So, Logan, while you're there in chat, can you tell me if that's a positive 8t, then how do I get rid of it? How do I move it to the other side? Okay. Anyone can tell me, how do I move this 8t to the other side?
Just minus it?
Yeah, you just minus it. I'm just going to minus 8t from both sides. That's going to give me negative 3s equals negative 17u minus 8t. And then I'm just going to get rid of this negative 3s. Now, I'm going to show you guys two things here. Firstly, to get rid of this negative 3s, we're going to divide both sides by negative 3. I'm going to show negative 3s, sorry. No, negative 3. I was right the first time. Oopsies. Now, what's going to happen here is we got two things are going to happen. Or there are two ways you can look at this. When I divide by, firstly, when I divide by a negative, all the signs in the other equation change. So that's going to change from a negative 17 to a positive 17. From a negative 8 to a positive 8 because I'm dividing by a negative. Then I have to remember I'm also dividing by 3. Now, a lot of students, and that's the answer. Now, the reason I'm being a little bit careful is a lot of students sometimes see questions that look like this. Let me show you. Negative x equals, let me say, we'll go with 14 minus k over 3, whatever, doesn't matter. This is something completely separate. And what they'll do, what happens is when they divide by negative, it changes. So then it becomes x equals negative 14 plus k over 3. Because the positive 14 becomes a negative 14, the negative k becomes a positive k. And sometimes they even rewrite it. X equals k minus 14 over 3. And this always shows up in multiple choice questions. And students go, whoa, 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 I can't see the answer. Obviously, they've made a mistake in the test because they haven't put down the correct answer. Usually they have, it's just they haven't realized they've jumbled up the order of the terms on top. But yeah, just in case you do see something like that, remember it's when you divide by a negative or multiply by a negative, it swaps the signs on the other side of the equation, and you can also swap the order. Now, this guy is actually something different. And you might say, no, it's not. It looks exactly the same. The reason this is different, and this has got to do with 3G, not 3E. And this is the subtle difference, is because notice how the two unknowns are on different sides of the equation. I was like, really? That's the only difference? I'm like, yeah, pretty much. Let's do two types of things here. Let's find the expression for P and find the expression for Q. So 16 plus 9Q equals 2P. We want to find the expression for P, which means you want to make P by itself. Really quickly, can someone tell me what I need to do to get P by itself? What's the first step? What do I need to do?
Divide everything by 2.
Beautiful. Divide everything by 2. Because there's a 2P, so if I divide everything by 2, then that's going to cancel that out. What that's going to give me is 16 plus 9Q divided by 2 equals P. Now I could have done 16 divided by 2 is 4 plus 9 over 2Q, but I'm not going to make it difficult for myself. I'm just going to write down this. That's it. That's done. The other side, making an equation for P is a little bit more challenging. The first thing again is on this side of the equation, we have a 16. So let's get rid of that 16 first by minusing 16 on both sides. That gives me 9Q equals 2P minus 16. Then I've got to get rid of this 9. I'm just going to do that. Divide both sides by 9. Gives me Q equals 2P minus 16 divided by 9. Now we actually have two ways to write this equation down. One in terms of P and one in terms of Q. So this gives us another idea of rearranging. This leads us to the sort of last idea, I think, transposing. And the transposing in many ways is pretty much the same thing as rearranging, but it's a little bit different, and I'll tell you why. Sorry, just enjoying a little bit of coffee there. Okay, so transposing means changing a formula to make a new pronumeral the subject. And this is, again, everything that you guys do in 3H. And the reason that I'm teaching you guys this is because ultimately this skill is pretty much the same as the skill that I just showed you before, as in, 2A plus 3B equals 5. Rearranging that into find out a way to express A or a way to express B uses the same skills as 2A minus 5 equals 3B, rearranging that. I guess usually the main thing with transposing though is that it's already in the form of one of them. For example, this one here is already in the form for F. Okay, it's already equal to F. I don't have 3B here. This would be like B. So if I want to transpose this to make C the subject, I'm just going to do the same exact rules that we've been doing. I've got 9 over 5 times C plus 32. So the first thing I'm going to do to get C by itself is look for what was the last thing that happened to the C. First, it gets multiplied by 9 over 5, and then it has 32 added to it. So believe it or not, the first thing I'm going to do is get rid of that plus 32. Minusing 32 from both sides, which is going to give us F minus 32 equals 9 over 5C. Now, my internet's bad, so I'm just going to slow down a sec. The last step is to divide by 9/5. Now, there are a couple of ways to do this. I would prefer just to do it like in a couple of steps, but in slow-mo. F e minus 32, all of that is divided by 9/5. Firstly, that is the correct answer, but we can tie this up a little bit. When you divide by a fraction, that's the same as multiplying by its inverse, multiplying by 5/9, which means the final answer becomes 5 f minus 32 divided by 9 equals C. Now, some of you might have done this in 2 steps in a different way. Some of you guys may have, instead of dividing by 9/5, some of you guys may have multiplied by 5 first and then divided by 9, but you would still get to this final answer. Doesn't bother me which way you get there, as long as you eventually end up at something like this. And what we've now done is we've now rearranged the formula and we've transposed it. Initially, F was the subject, and we've transposed it to make C the subject. Now, the advantage of that is, that shows up all the time in physics and chemistry and maths and engineering all the time, because you might have a great equation that calculates the amount of temperature increase for the amount of time that something's been heated for, but you don't want to know that. You want to know, well, how long do I have to heat this thing up to get to this certain temperature? You might want to rearrange it to make T the subject. Use this formula, by the way, at the end. Use this formula to find C when F is 212. Well, now we have a formula for that. 5 times 212 minus 32 divided by 9 equals C. That actually comes out to be, I'm going to use my calculator really quick. 212 divided by 32 gives me 180. 180 times 5 gives me 900. Divided by 9 gives you 100 degrees. 100, sorry. If you hadn't worked out, by the way, F and C, this is a really common formula. This is the formula used for calculating difference between Fahrenheit and Celsius. So honestly, most teachers will use this example. And yeah, 100 degrees Celsius, so the boiling point of water, is 212. There was lots of other things you can talk about with Fahrenheit and Celsius, but I'm not going to talk about them now. But yeah, that's it for the lesson. So I'm going to wrap it up there. Thanks for listening.